Hello everyone. Welcome to the mini lecture on advanced manufacturing technologies for welded structures. I'm Huang Bin. Today we will learn the relevant content of robot welding inspection technology together. I hope that through this lesson, everyone can master the basic methods and skills of robot welding inspection technology. Next, we will divide it into the following 6 parts. First, the overview of robot welding inspection. Second, classification and standards of welding defects. Third, inspection technology and methods. Fourth, quality control and case analysis. Fifth, quality and responsibility. Sixth, summary in the future. Let's first look at the overview of robot welding inspection. Welding quality is directly related to engineering safety. If there are defects in welding, it may lead to structural failure, major safety accidents, and huge losses. For example, the welding quality of large-scale projects such as bridges and buildings is not up to standard, which is like planting a time bomb. Welding inspection can detect these defects in time, ensure the welding quality up to standard, and prevent structural failure. Meanwhile, accurate inspection can also improve production efficiency, reduce rework and waste caused by quality problems, and save costs for enterprises. The welding inspection process covers multiple links. Before welding, it is necessary to check whether the welding materials, equipment and process parameters meet the requirements, as well as the size and cleanliness of the weld groove, which is the basis for ensuring welding quality. During the welding process, it is necessary to monitor parameters such as current, voltage and speed in real time, observe the welding pool and weld formation, and adjust the welding process in time once problems are found. After welding, it is necessary to check the appearance quality of the weld, such as undercut, weld overhang and surface porosity, etc., and use non-destructive testing technology to check whether there are defects such as lack of fusion and cracks inside the weld. Finally, collect and sort out the inspection data, analyze and evaluate it, formulate improvement measures according to the results, and continue to optimize the welding process. However, this technology faces some challenges. Internal defects are difficult to observe directly and need to be identified with the help of advanced technology such as ultrasonic testing and X-ray testing. Complex welds have diverse structures and shapes, making detection difficult. They must be inspected by intelligent detection technology such as AI visual recognition and laser scanning. After understanding the overview of inspection, let's look at the classification and standards of welding defects. According to GBT 6417-2005, welding defects are divided into 6 categories. Cracks, such as crater cracks, appear at the crater at the end of welding and affect the weld strength. Transverse cracks may lead to weld fracture. Longitudinal cracks, produced in the longitudinal direction of the weld, affect the overall property and reliability of the weld. Lack of fusion and incomplete penetration. Lack of fusion means that the weld metal and the base metal are not completely fused, and incomplete penetration means that the weld is not completely penetrated. Both affect the strength and reliability of the weld. Voids, porosities are the holes formed by gas entering the weld during welding, which affect the strength and sealing. Shrinkage cavities are formed by weld shrinkage and also need to be strictly controlled. Shape defects. Undercut will affect the appearance and structural strength of the weld, and may also lead to stress concentration. The weld overhang affects the quality and appearance of the weld. Burning through is a hole formed by the weld being burned through during welding, which may lead to weld defects and needs to be strictly controlled. Solid inclusions. Slag inclusions and oxides can affect the quality and property of the weld. Other defects. Spatter and arc injury can affect the appearance and quality of the weld. Here are pictures of several types of defects. 1. Undercut is a depression formed by arc ablation on the edge of the weld, which affects the appearance and structural strength of the weld and needs to be strictly controlled. Undercut may lead to stress concentration and affect the service life and reliability of the weld, so measures should be taken to avoid it. 2. Porosities are the holes formed by gas entering the weld during welding, which affect the strength and sealing and need to be strictly controlled. Porosity may cause internal defects of the weld and affect the overall performance and reliability of the weld, so measures should be taken to avoid them. 3. Cracks are cracks that occur in the weld or heat-affected zone during the welding process, which affect the strength and safety of the weld and require great attention. Cracks may lead to weld fracture and affects overall property and reliability of the weld, so measures should be taken to avoid it. There are many inspection technologies and methods. Visual inspection can observe surface defects such as undercuts, weld overhangs and surface porosities. It is simple and convenient, but is limited in accuracy, and it is usually used in combination with other methods. Penetrant testing can identify tiny surface cracks and is suitable for surface opening defect inspection, but the operation and analysis should be strictly standardized. Ultrasonic testing can locate internal defects such as lack of fusion and incomplete penetration, with high accuracy and can detect internal defects. Ultrasonic testing can quickly locate internal defects and provide an important guarantee for welding quality, which requires professional operation and analysis. X-ray testing can see through internal defects such as porosities and slag inclusions, and visually display internal defects with high accuracy. X-ray testing can visually display internal defects and provide accurate assessment of welding quality, which requires strict operation and analysis. Magnetic particle testing is suitable for crack detection of ferromagnetic materials, with high sensitivity and can detect surface and near-surface defects. Magnetic particle testing can quickly locate cracks of ferromagnetic materials and provide an important guarantee for welding quality, which requires professional operation and analysis. There is also intelligent detection technology. AI visual recognition can monitor weld formation in real time and automatically identify defects. Laser scanning allows 3D modeling to analyze weld dimensional deviations. In terms of quality control, equipment calibration, environmental management, and process optimization are all critical. Equipment calibration can ensure the accuracy of welding gun trajectory and reduce welding deviation. Controlling environmental factors such as humidity and shielding gas purity can reduce welding defects. Adjusting process parameters such as current and welding speed and optimizing welding process can improve welding quality and stability. Let me give you 2 examples. Damp welding wire will lead to rework of batch products and affect welding quality. Incomplete penetration of the weld of bridge leads to local fracture, which threatens the structural safety. Both warn us to perform strictly control of all links. Here is a case. A high-speed rail welding team. They uphold the spirit of craftsmanship, continue to seek technology innovation, and achieve zero-defect welds through high-precision inspection technology, thus ensuring the safe operation of high-speed rail. There are many we can learn from them. We must keep a sense of responsibility since negligence in the testing process may lead to serious consequences. We must carry forward the scientific spirit, make decisions based on data, and reject empiricism. We must strengthen teamwork and cross-domain cooperation to improve testing reliability. Looking ahead, there are new trends in inspection technology. Digital twin technology can predict defects through virtual simulation and improve detection efficiency and accuracy. Automated inspection robots can replace high-risk manual operations and improve inspection efficiency and safety. Of course, this requires versatile talents who must not only master testing technology, data analysis, but also have professional ethics. In short, inspection technology is the gatekeeper of welding quality. Quality needs the joint guarantee of technological ability, sense of responsibility, and innovative spirit. I hope you will take this technology seriously and contribute your own strength to the project construction in the future. This lesson ends here. Thank you for listening. See you.